So what we're going to look at this morning is we're going to look at polynomial division. And the idea here is it's very similar to long division. So let's say we have this. Start out with long division. Let's say you have 2 goes into 37. So you go with 2, and 2 is going to be doing all the work here. 2 will go into 3 at most one time. So 3, there's our 2. I'm using arrow because it's not equal to 1, it's at most 1. So it goes in at most one time. So I put my 1 here. But then we say 1 times 2. Do this multiplication. And that is an equal sign. 1 times 2 is 2. So we take that 2 and we put it right here. We subtract, we get 1, bring down the 7, and that's our first cycle of division. Now we do a second cycle. We take this 2 and we divide it into the entire 17. Goes in at most 8 times. Then we do 8 times 2. So we get 16. Put the 16 here, subtract, and we get a 1. And there's nothing else to bring down. We're out of numbers. And we're not going to do a 0.0 or anything like that. So that's our second cycle of division. So what did we get for an answer? Well, we get 18, remainder 1. And this R stands for remainder. Or we'll say 18 plus, and then we take the remainder and we divide it by the divisor. That's the other way of saying you got a remainder. And you can try this. If you take 37 divided by 2, you'll get 18.5 or 18.5. So that's long division. For polynomial division, we're going to do something incredibly similar. So let's say we have this. So in this case, we've got a division. Trinomial divided by a binomial, or we have a third degree polynomial and a, second degree polynomial and a first degree polynomial. What we do is we put this in long division form. That's what we're going to do first. And here, let me rewrite this. Make this a little smaller, make sure it fits. A little more compact. So what we're going to do, we're going to go through the procedure of how to do long division with polynomials. So we have our x. One thing we want to make sure we do, put everything in standard form. So for this polynomial, highest degree term, then the next highest degree term, and then find the lowest degree term. Or we have our leading term, say degree 2, degree 1, degree 0. This one, it's going to be degree 1, degree 0. You want to have them in this sort of descending order of degree. We want the terms listed in that descending order of degree, or what we call standard form, for this to work. So degree 1, degree 0, degree 2, degree 1, degree 0. Once we've got it set up like this, now we can do our division. And it's going to be the lead term of the divisor polynomial. This is called the divisor. This is called the dividend. So the divisor is what's going into something. The dividend has the divisor going into it. So we'll have this divide into this. Now, in this case, we don't need to use an arrow. It'll go in exactly. It'll go x times. Now, this x, we can think of this as an x squared column, an x column, and a constant column. So I'm going to put this x in the x column. Now, we take this x and it multiplies everything in the divisor. Get x squared plus 5x. We subtract. Now, when we subtract, we do this sort of, and then we term by term. So x squared minus x squared, that's going to be 0. 8x minus 5x, that's 3x. And we bring down the next available term. Because we have something in the x, for the x terms, now we go to the constants, or the constant column, bring that down. Because that's the column that's next. If there was some other column that was there, then we would bring down whatever term was in that column. But in this case, it happened to be the constant column that's next. We brought down the constant. And so that's it. That's our first cycle of division. So now we do our second cycle. This lead term will divide into that lead term. And we get 3, a constant. So you have the squared, the x, the constant. We've got a positive 3, so we put in plus 3. Now this plus 3 will multiply to the entire divisor. We'll get 3x plus 15. So we put 3x plus 15. Again, the product of this and this goes down here. 3x minus 3x is 0. 15 minus 15 is 0. So we get 0 as a remainder. So what did we get for an answer? Well, x plus 3. When we divide this polynomial by that polynomial, we get x plus 3. Now, what does this say? Well, think about it. If you have 15 divided by 3 equals 5, well, we know this means that 3 times 5 equals 15. So same thing here. If this divided by this is x plus 3, then this means x plus 5 times x plus 3 is x squared plus 8x plus 15. So in the same way we can use division to discover multiplication, same thing with this. We can use this division to discover that x plus 5 times x plus 3 gives us the original polynomial. This lets us factor this polynomial. Now we have it factored out. So let's take a look at some others. Now this is a procedure that really does take practice. It's one of these things that you just want to work on it. And the more you work on it, eventually you start to get used to it. So if you're looking at this like, yikes, this is kind of a lot to remember, don't worry, it is a lot to remember. practice with it. The more you work with it, the more it's going to start to stick. All right, let's take a look here. So let's say we have this. So let's check, make sure they're in standard form. Degree 2, degree 1, degree 0. Okay, that one's good. Degree 1, degree 0. Cool, perfect. Put them in long division form. So again, this leading term for the divisor is what does all the work. So, and when we start our division using leading terms. So this leading term, and well, over here, this is the leading term. So that's how we start out our division. Leading terms are always dividing into leading terms. So 12x squared over 3x. And that's going to give us 4x. So we can think of an x squared column, an x column, and a constant column. Let's put the 4x in the x column. Now we take the 4x, multiply the entire divisor. And so we get 12x squared minus 8x. So that's what goes under here. Now, when we subtract term by term, we want to be a little careful. 12x squared minus 12x squared, okay, that's 0. But this one is x minus negative 8x. So x minus negative 8x. Negative and negative becomes a positive. So you want to be careful with these. You always want to refer to your subtraction here. This minus this with its own minus sign. So that double negative becomes a plus. You get 9x. So let's take a look at the next column. This is the x column. The next column is the constant column. Bring down our constant. And that's our first cycle of division. So now we do the second cycle. So again, lead terms. This one, and now this lead term. We're going to get 3. So plus 3 in the constant column. We would take 3 times the entire divisor. To get 9x minus 6. And so now we subtract. So 9x minus 9x, okay, that's going to zero out. But take a look at this. Negative 4 subtract minus 6. Well, double negative becomes a positive. So that comes out 2. All right. Now there's nothing else to bring down. So that means And since this didn't turn out to be 0, this is a remainder. So the solution is 4x plus 3, remainder 2. But the other way to express remainders is to add the remainder when it's divided by the divisor. So remember, we had 18 remainder 1 when we took 37 and we divided by 2. And we rewrote this as 18 plus 1 over the divisor. And sure enough, if you take 37 divided by 2, you get 18.5 or 18.5. So same thing here. Our answer now becomes 4x plus 3 plus 2 divided by the divisor. And so that's going to be our answer. Now, does this actually work? Well, what this says is this. If we take 3x minus 2 times this, we should get the original equation back. Well, let's see if we do. So what we figured out was that 12x squared plus x minus 4 divided by 3x minus 2 equals 4x plus 3 plus 2 over 3x minus 2. That's what we got as an answer. So this should mean if we take 3x minus 2 and multiply it to this, we're going to get that. Again, it's kind of like if you had 15 divided by 3 was equal to 5. Well, this means that 5 times 13 will give you 15. Let's see if that's what happens. So let's do the multiplication. Well, we're going to distribute this entire 3x minus 2 to everything here. So what we'll get is something like that. Well, we have some cancellation here. 3x minus 2 in the bottom, 3x minus 2 on top. Those will cancel. This we can FOIL. Now the 2 is still here. I don't want to forget that. So 4x times 3x is 12x squared minus 8x plus 9x minus 6. And don't forget we have this plus 2 over here. So you get 12x squared plus x. Negative 6 plus 2 is minus 4. And sure enough, we get the original polynomial back. Not equation, but polynomial. All right. And again, this is, I might have called this an equation earlier. It's polynomial, not equation. Sorry about that. All right, so we multiply the answer we got, 4x plus 3 plus 2 over 3x minus 2. We take that answer, multiplied by 3x minus 2, we get the original polynomial back. So it works. So far, so good. Now, let's take a look at another one. All right. Now, the issue here is we have missing terms. Now, let's make sure it's in standard form. Degree 5, degree 4, degree 3, degree 2. So far, so good. Degree 3, degree 0. So far, so good. Higher degree, lower degree. That's fine. But we're missing terms. We need, when we do this division, we want to fill in missing terms. So if we're missing an x term, we're going to fill it in with a 0x. If we're missing a constant term, we fill it in with a 0. If we're missing an x squared term, we can fill it in with a 0x squared. So we want to put in, these act like placeholders is really what they're doing. We want to make sure we put those in. So what that means, our division is going to become this. So now we have all the missing terms accounted for. Degree 5, degree 4, degree 3, degree 2, degree 1, degree 0, degree 3, degree 2, degree 1, degree 0. And so we filled in these missing terms by using 0x squared, 0x, or 0x and 0. So now that we have them there, let's do our division. So it's going to get a little cramped in here. All right. So now let's do our division. And we're going to have to kind of cram this in here a little bit. But first cycle of division, again, lead terms. We're going to be dividing lead terms. And this one's going to be doing all the work. So let's start out 2x to the 5th divided by 2x cubed. Well, that's going to be x squared. So let's put x squared in the x squared column. Then we take x squared, we multiply through by x squared. Let's check my arithmetic real quick. So far, so good. So far, so good. All right, it's looking good. So this is what we write down here. All right. So now we subtract. Now 2x to the fifth minus 2x to the fifth is 0. All right. We now have negative 8x to the fourth minus 0x to the fourth, which is the same as minus 8 subtract 0. And that doesn't change anything. So we just get minus 8 x to the fourth. 2x cubed minus 0x cubed, that's just 2x cubed. Now, we're going to get a gap with this one. X squared minus x squared is 0. And then we bring down the next term, which is 0x. But we've got this gap here. So we got to put a placeholder in the gap. And so that's where we put in another 0, x squared. So when we get a gap like this, we got to put in a placeholder. X squared minus x squared is 0, x squared. All right, so we've got everything. Now, that's our first cycle of division. Now for the second cycle. So we get negative 4x. So we have minus 4x, again in the x column. Now we take minus 4x. We multiply everything by it. Oh, this is the fourth. Let me check my arithmetic here. So we have minus 8x to the fourth. This will be minus 4 times 0, 0x cubed, 0x squared, minus 4x. All right, it looks good. So minus 8x to the fourth plus 0x cubed minus 0x squared minus 4x. So we subtract. So what we end up getting here, negative 8x to the fourth minus itself, it just goes away. 2 minus 0 is just 2. 0 minus negative 0, which is the same as 0 minus 0. Well, that's 0, but we're going to get a gap here. So we're going to say 0 minus 0 is 0. So 0x squared. Again, we're trying to avoid a gap. 0 minus a negative. What's going to be positive 4x? And we bring down the next one, plus 0. And then that's our second cycle of division. So now for a third and what looks to be our final cycle. We take, again, lead term divides into lead term. And so we get 1. We now take this 1, we multiply everything. And when you multiply 1, it doesn't change anything. And so we put this here. We subtract. And again, something minus itself goes away. 0 minus 0 goes away. 4 minus 0 is 4x. Or 4x minus 0 is 4x. 0 minus 1 is subtract 1. And there's nothing else to bring down. So we're done. That's the end of our division. So what did we get? Well, we got this. So the answer is x squared, minus 4x. Excuse me. X squared minus 4x plus 1, remainder 4x minus 1. So what that means, again, we write the remainder when it's divided by the divisor. X squared minus 4x plus 1 plus 4x minus 1 divided by, well, excuse me. We get this. Or we don't need the placeholders anymore. So we can do without those in the answer. And that's going to be the solution. All right. Now again, this kind of thing, it takes time. It's one of these things you just want to practice at it and it starts to kind of grow on you, get used to it. Now I want to talk about something called synthetic division. Synthetic division is used in a special case. It's when we have this. It's we have p of x divided by x plus or minus a constant. And this is the particular kind of division we end up doing with synthetic division. And it just makes things faster. It's kind of a super shortcut. So let me give you an example of how this procedure goes. It's a little bit different. So let's say we have this. So the way synthetic division works is this. If you have p of x divided by x minus c, what you do is you take the c and you put the coefficients of p of x. And again, these need to be in standard form. But you just list the coefficients of p of x after p of x was put in standard form. You're going to draw a line, and instead of subtracting, like we do in long division, we're going to add. And what typically happens is this. We're going to bring down the first term. It just drops down. And then we're going to multiply everything by c, put the product of here, add the terms, coefficient for p of x, and then our product will get a number. multiply this number in C, put in the product, add it to a coefficient, get the sum, and then multiply and continue. And I'll go through the steps. Now, if we have this, if it's x plus c, we set up, again, the coefficients of p of x, again, in standard form. And then we have our plus sign. We'll bring down the first coefficient. And then we'll have minus c out here. So when we have x minus c, got a positive c out here. X plus c, got a minus c out here. So let me go through the procedure. Let me show you how it works. So this is a minus c. We have the positive 2. Now, our polynomial's already in standard form. Degree 2, degree 1, degree 0. So we just list, and I think I called them terms, we really just want to list the coefficients. Bring down the first coefficient. I think I called it a term earlier. It's really just the coefficient. Bring that down. This is how the process, so this is our setup for synthetic division. We set it up like this. Now we put it to work. This is going to do all the work. This times this gives us 4. We add 1 and 4, as we're adding, we get 5. Then we take 2 times 5, and we get 10. Negative 10 plus 10 is 0. So we're actually done. Now, what did we just do? Well, we've got to interpret what this means. So this column is the remainder column. This is the constant column. This is the coefficient for x. And if we had more terms, we'd have the coefficient for x squared and so on. But we don't. We just have x, constant, and remainder. So our answer is this. 2x plus 5, and we have a remainder of 0, so that's it. It's 2x plus 5. So this means if we take this polynomial, divide by x minus 2, we get 2x plus 5. All right. So again, this is one of those things where, practice makes perfect. Let's do another one. So let's say we have this. Now again, we want to make sure everything's in standard form. Degree 7, degree 5, degree 3, degree 0. Degree 1, degree 0. And we're going to use synthetic division. Now, we want to be careful. We're missing some terms in this top polynomial. So we need to put some insertions, some placeholders. So we need a 0x to the 6th plus x to the 5th plus 0x to the 4th minus 10x cubed plus 0x squared plus 0x plus 12 divided by x plus 2. Now the power of synthetic division is that it makes a lot of this easier, because this is going to be, kind of a lot of work if we're using long division. But if we use synthetic division, hopefully this will go faster. Now let's take a look at this. We've got a +2 or a plus C. So that means we take the minus version, minus C, on the outside. And now we list the coefficients here. 1, 0, 1, 0, -10, 0, 0, 12. So let me double check that. We got 1, 0, 1, 0, -10, 0, 0, and 12. So we've got it. Bring down the first coefficient. Don't want to call it a term, coefficient. And then let's do our multiplication. So when we do that, we get -2 times 1 is -2. Add these, and we get -2. Then -2 times -2 is +4. 1 plus 4 is 5. And notice I'm careful trying to line up everything in my columns. -2 times 5, -10. 0 plus -10 is -10. -2 times -10, +20. -10 plus 20 is +10. -2 times 10, -20. 0 plus -20, -20. -2 times -20, +40. 0 plus 40 is 40. -2 times 40, -80. -80 plus 12 is 68. So what we did, -2 times 1, -2. Then we add these, we get -2. And then -2 times -2 is +4. Add these, we got 5. -2 times 5 becomes -10. Add these, this is 0, -10. These are two separate columns here. 0 and -10 is -10. -2 times -10, +20. +20 plus -10, +10. -2 times +10, -20. Add these two, you get -20. -2 times -20, +40. Add that to 0, you get 40. Then -2 times 40 is -80. Add that to 12. I'm sorry, you get -68. Doesn't hurt to check your arithmetic. All right. So how do we interpret this answer? Well, this is the remainder. Constant coefficient, coefficient for x, coefficient for x squared, coefficient for x cubed, coefficient for x to the 4th, coefficient for x to the 5th, squeeze that in there a little bit better, and then coefficient for x to the 6th. And they work in this order: remainder, constant, x, x squared, x cubed, x to the 4th, x to the 5th, x to the 6th. Or you can think of it in this order as being in standard form. So, putting that together, we've got this. One x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40, remainder -68. Now again, we're going to rewrite this remainder differently. So what we're going to do instead, since our divisor was x plus 2, x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40 minus 68, because it's got a negative, over x plus 2. And that's going to be our answer. All right. So that's the idea of synthetic division. And to be honest, this is much faster than using long division to solve this problem. Now, there's a couple things to mention in this section, some observations.